Hello and welcome to Surveyor Says, the podcast from the National Society of Professional Surveyors. Each week, we bring you fascinating guests that are involved in the profession of surveying. We cover a lot of ground, including Table A Talk with Gary Kent, Point of Order with the NSPS Joint Government Affairs Team, Future Focus, highlighting current and future leaders of the profession, and everything survey-related in between. Thanks for joining us here on the podcast, and hope you enjoyed listening to this episode of Surveyor Says. Hello and welcome to another episode of Surveyor Says. This is your host, Tim Burch, and I have a little bit of a treat this week because this gentleman I met a couple of weeks ago at the New Jersey Professional Land Surveyors Conference. He is a student at New Jersey Institute of Technology, which I had explained to me last night is, think of MIT, but in New Jersey. So that dynamic was kind of fun to throw, and it was actually an NJIT alumni. So he said that proudly. But today I'm speaking with Michael Bleeker. Michael, it was great meeting you over there in Atlantic City, my first time into Atlantic City. And I guess we met at the alumni gathering there for NJIT and Rowan. Great event. And your presentation and demonstration with what we're going to talk about today was phenomenal. And I think you really captured the imagination of a lot of the attendees. But so, Michael Bleeker, who are you? Where did you come from? And what are you bringing to the geomatics and the surveying profession today for us?
All right. Well, as you said, my name is Michael Bleeker. I recently graduated from NJIT with a mechanical engineering degree. And I am back in for a second undergrad for the surveying engineering technology degree.
Very nice.
Born and raised in North Jersey, bounced around a bunch of different towns, but I'm currently living out of Bloomfield and I'm working out of Upper Montclair.
Nice. So first question that I have, maybe the listeners would have as well. Okay, you did one degree. What got you engaged to want to come back and get the second degree and make it surveying? I mean, so tell us what engaged you to want to do that? Because I won't say it's a big stretch, but it's really not. But I think your story of how you tied that all together really sets off this conversation, kind of sets the tone for what we're going to talk about today.
Well, I've kind of been exposed to surveying my entire life. I come from a family full of engineers, architects, surveyors. My father is a surveyor. Two of my uncles are surveyors. One's an architect. Some have civil engineering degrees. So growing up, I was always exposed to the kind of, civil engineering or, kind of world. And that was always in the back of my mind when I was trying to figure out what kind of career path to choose, because I saw all of my family members doing it successfully, So, but I was always kind of mechanically inclined. I liked robotics. I had a robotics class in high school that made me super excited for college. So I chose mechanical. But, I found, especially during COVID, I didn't really enjoy just sitting behind a desk, doing CAD programs all day, every day. I, kind of hungered to be outside. And I realized, well, surveying uses robotics and does all those kinds of things. And it just, all the gears started clicking together, so to speak. And I realized that, I will really enjoy, this kind of career path if I try to just combine all of my knowledge and hobbies and passions, consolidate on surveying.
All right. So I guess we'll just do the kind of the big unveil of what you dropped on us and the knowledge you dropped on us at the conference. Tell us about your project, your vision of really applying what you love about robotics, what you know about surveying, what you're trying to learn, and into this big project that you, like I said, you laid on us and really wowed the crowd.
So the project we're working on, it was a fully autonomous LiDAR and photogrammetry SLAM rover. So SLAM is simultaneous localization and mapping. So if anyone's familiar with, laser scanning and point clouds, it's basically, doing that, generating a cloud but doing it live, and it's moving around the environment and creating a map in real time. So, and that's probably the future, in my opinion, of, surveying. But, I guess, I don't know how technical you want me to go into it.
No, go for it. That's really what we're here for, because there's so much technical going on in our profession that, laying out your vision and putting this project together, I think that that really helps establish where you're going and where the industry is going.
Yeah. So that's one of the best technologies for, mapping is right now, kind of trying to emulate, the human features, human vision. So photogrammetry, it works best by trying to emulate, the human eyesight, trying to do our depth perception. So on the rover, we have a stereo camera that's run by AI and incredibly powerful NVIDIA computers, and, does all the, the depth perception calculations that, the human mind just does automatically, and generates a point cloud and a map based off of that. And now you hook up a GPS to it, put a decent computer in it, and you can have it just moving around job sites autonomously. You control it from a base station, somewhere in an office, and you have this rover running around generating a map.
Yeah, exactly. And that's, all right, you've got all of these components, all of these remote sensing pieces. What kind of a platform do you currently have it on, and where do you see this thing going from there?
So as of right now, it's basically built on a kind of beefy RC car, with a decent off-roading wheels and a suspension and all that stuff. And that's probably, formats like that are probably going to become standard. Maybe, changing the steering mechanisms or whatever will likely happen. But, deploying some sort of rugged, kind of remote controlled drone is pretty much becoming the norm, especially in farming equipment, stuff like that. That's one of the biggest sectors that is adopting this technology. They have, massive rugged machines, surveying fields and, determining the quality of crops and, just measuring everything that possibly can be measured.
Exactly. Well, and what impressed me about the vehicle you actually, that you've put together, even as well, and I guess that's the thing about the remote control car industry now, and how capable that has gotten, both gas powered and the electric side of things. How rugged they are, and being able to adapt all of those remote sensors onto that platform. Just to even to conceptualize what's going on. That was a really ingenious start to all this. So I do have to tip my cap to you for putting that together, because that's the one thing that that I think that that I think is going to be the next frontier. Is yes, we're already flying stuff in photogrammetry and LiDAR and all of those things. We're now doing stuff with bathymetry and basically underwater drones. The whole capability of on the surface, really, we haven't seen a lot of that just yet. And I think you're onto something here.
That's, the biggest struggle with a lot of it is, everyone's trying to make money off it, so every single time some new emerging technology comes out, someone's doing research in a school, some big company snatches it up, makes it all privatized. And it's hard to, conceptualize how much it's really growing, and how fast it's really all changing.
Exactly.
It's, there's a lot of demand for, mapping and things like tunnels and, old mines and, a lot of the stuff that the public doesn't really see on a day-to-day basis, but the industries are hungry for, improvements in their workflows.
Exactly. And what I appreciate about what you're trying to do with this platform, it's, I guess this is the age old thing that we've had some naysayers in our profession say, well, you're just, you're going to eliminate jobs. And no, this is going to expand opportunities for people. And I mean, I look at it as and I look back at my career and some of the places that I didn't, a person could not go into, environmentally shouldn't go into, whether it's, and I grew up in Central Illinois. So a couple of places were some grain elevators, and places where this really good for somebody to be in. Something like this, you could stick it in this environment and drive it around and control it and collect all of these things and not be hazardous to that surveyor, to that operator. So I'm looking at little things like that, and just it's amazing the capability that a platform like this is really opening up.
No, absolutely, I agree. And to say on your point, the naysayers, a lot of people say that surveying is dying, and that's not really the case. It's simply evolving. You think one generation ago, you had, when you're doing a stakeout, you had 4 guys go out with a tape and a theodolite and, do all their layout, but now we have, robotic total stations. The job of 4 guys can be done by 1. The profession still exists. We're still here. We're still making money. We're still growing as an industry. And this is really just kind of the next step. There is a dire need of, surveyors, for every, in New Jersey specifically, every 60 men that retire, surveyors, not necessarily men, only really 10 are graduating from New Jersey schools, 15. And, technology like this helps bridge that gap, I think.
Exactly. And obviously, as we've seen as well, that it's not even just the licensees. It is the technician side, whether it's field crews or office staff, drafters, what have you. We're having that technical side we need to backfill as well. And I think this was a great concept. So let's talk about a little bit about the challenges of this. I mean, you're doing this as a project within school. What kind of the technical challenges? Because you rattled off a whole bunch of different sensors. What's been the challenge of making this thing? I mean, each of these sensors talk to each other and being geo-referenced and all of this stuff. I mean, that's some heavy duty thinking and programming here.
Yeah, that's honestly the biggest, like I kind of mentioned something to the effect before, but trying to find information on how to make it all work is the toughest thing because, like I said, you start, the student that originally developed the algorithms to make these SLAM scanners work, originally, a lot of his stuff was open source. He published it on the internet, and then a company bought him, and now he's making some company millions of dollars somewhere. But they took all that information off the internet. So it's this constant struggle of like, okay, everyone's developing these new sensors, and people start figuring out how it works, and then they get snatched up by companies, and then the information disappears. So it's a lot of trial and error, just beating your head against the wall over and over and over again until eventually you get through, because, people are doing it. It's obviously doable. People are making the tech for it. It's just developing the kind of, kind of persistence mindset, trying to not, burn out, get too frustrated, trying to regulate your own emotional regulation is probably the toughest part of the technical side.
Oh, I bet. Well, and then I guess the other big challenge to this, the funding for putting these pieces together. It's not like you just go down to the hardware store and pick up this scanner off the shelf for $50 or whatever. I mean, we're talking some significant value here. How have you been able to fund putting all of these things together? Have you found some industry partners, or how's this thing been able to financially come together?
Unfortunately, I have to give a lot of credit to my advisor, Dr. Potts. A lot of it is funded by the school, different research professors, throwing money around, some small grants, things like that. Even the society has helped us out a little bit. The New Jersey Society of Professional Surveyors. It's, I don't have a huge hand in the money collection at the moment, but it's the money's out there. People are getting excited about this tech. As obscure and as few people seem to have eyes on it. Everyone wants to see the industry, progress. They want to move forward. They want to throw money at these kinds of things because, it's the future.
That's good. Well, then, with that little shout out to Dr. Laramie Potts. Yes. He is a wonderful leader on all of these things. And you're right. It's, I guess that's the one problem I've always heard throughout my career with surveying curriculums is that securing funding and securing backing from not just, the software companies, the equipment companies. It's one thing for an engineering curriculum to say we're putting together all this research and get these grants and things. Surveying it's an expensive curriculum to put together simply because of the equipment. So
yes,
having a program and a state society that's been willing to help and put some dollars together to help fund not just the program, but obviously the projects like these. Kudos to Dr. Potts and the society for helping that out. Because, hey, you got to spend some money to make some new technology to make some money, right. And you've done a great job with that. So, I guess from putting this together, and it's by no means done yet, you're going to continue to tweak and make improvements and things to this project. What's in some of what's lessons learned in putting this all together? Not just what you're going to improve on, but how's it made you? Has it made you look at the profession any differently, and how to approach how we get some of our tasks done, and how we become more efficient in what we do? What are some of the lessons learned during all of this?
I've learned so much from it. It's hard to distill it down into one topic. It's making me realize that the sky is the limit. A lot of older guys, they learn one workflow, with one instrument, and, they kind of just do that, and and that's fine. But, technology is evolving so rapidly now, and it's becoming so technical. Like, a lot of people will lament the fact that, surveying now requires a college degree at least in New Jersey. But the rate at the technology is moving. Like, what I'm learning in my classes, it's fundamentally an engineering degree now. We're learning about, lasers and doing the mathematics for photogrammetry and all the parallax calculations, stuff that, was not done in the past. It's becoming, increasingly, I guess, white collar is the way to put it. It just requires a lot of, technical knowledge and experience, and it's just going to be a completely different landscape within, probably the next 2-3 decades.
Exactly. Well, I guess that kind of leads into that next question. I mean, you've obviously been in formal education through your mechanical side, now getting into the surveying side and all the things you're putting together here. And I think you hit on it a little bit, that it's surveying has historically been really looked at as a blue collar profession. And there's so much more technical side, so much more that needs to be educated and formally learned, that it's not just out cutting brush and running lines and things like that. It's all this high tech data collection that. So I guess how do you feel that do we make this balance between formal education? There is experience. There's all these things that need to be put together. But I think you've made a kind of a great pitch that, hey, there's a lot more formal side to this, that because it is so technical.
Right. And that's, when you rip apart one of these instruments, there's a complicated computer in it. There's lasers, there's batteries, there's all sorts of, all of our, humans' cutting edge tech is all crammed into these, really neat looking, total stations and things like that. And it's, very difficult to wrap your head around. I mean, granted, it's designed to be as user friendly as possible, so that the layman can use it. But, making these things, truly understanding how they work is, becoming a challenge. It's not something you could just pick up on a weekend, right out of high school anymore. You need to understand, the mathematics and the electricities and the chemistries and, the logic, that's going behind all these instruments. How are these measurements really being made? It's not as intuitive as, pulling a tape anymore, or reading a number on a transit. Like, it's
right.
And that's, the tough part is the barrier to entry is increasing, but
exactly.
It's kind of necessary.
Oh, exactly. And I even think back, and good thing is this will predate you by quite a ways. But I remember the introduction of the personal computer, and I mean, obviously there were mainframes when I was growing up that I'd never touched. But once you got to the personal computer, yeah, you really had to know what you're doing, to which disk to put in and this things. But like you said, it's gotten down to the point where literally anybody, our grandparents now are running personal computers, and it's a very complicated machine, but obviously it's done in a manner where everybody can run it. And that's what I think. I think that's the important thing we got to keep a vision of with surveying. It is very complicated, all of the stuff that's going on because of the technology, but it's allowed us to do so much more. So we've got to be able to wrap our heads around that and really know how to work the profession around it.
Yeah, and that's what we're gonna say.
No, well, and I guess that kind of leads into my next question of your, and we talked about Dr. Potts and others. How has the influence of older generations, your mentors, professors, teachers, and industry professionals, how has that kind of bled into what you're trying to apply? I mean, it's not like you're blind to the rest of the world and you're taking all of this and you're building this cool toy without some input from others, because obviously you want to make it useful. How has that influence between your formal education and the outsiders within the profession? How's that influenced where you've taken your projects and your mindset for the future?
I think one of the biggest influences was when I was a freshman mechanical engineering student, years ago now. One of my first professors that taught me 3D CAD modeling, he said, no matter what you do it with passion. And that's a lot of the really big personalities I've met in academia, is basically just trying to reignite that childish curiosity. A lot of people lose that as they get older, but never stop imagining what's possible. Even Dr. Potts, if you get him, he's a geodesist. You get him talking about the axis of the Earth and how it wobbles and how hard it is to measure and calculate. That's what he did, I think, his thesis on and stuff like that. It's the energy that some of these these guys who never really lost that the glint in their eye. That energy is probably the most important thing I've learned from all of my mentors and things like that. The people that are, not just excited to live life, but excited about the possibilities and, want to get the next generation excited. And that's, in my opinion, the biggest struggle in, this world nowadays where, with all the social media and the politics and all the insanity, is how do you, keep a cool head, be optimistic, and keep, encouraging people to keep working and, to keep charging forward, keep developing new technologies and, have fun while doing it.
Exactly. No, that's you're spot on there. So I'm going to kind of flip the script a little bit, because obviously you're a little bit older, having already been through a degree program once, and now you're going back for another bite of that apple. These young kids coming in now, the freshmen, sophomores that are coming into the program now. How do you see, what you're building upon and what you've learned? How are you able to apply that and really become that mentor for those younger, that I hate to say generation, because you're all really the same generation, but that next wave of students coming in, they haven't seen what you've seen, and how do you relate to them and transfer all this stuff?
Well, doing everything I can to kind of pay it forward, but I think the biggest struggle with the current or the young generation now is they were the first real generation to be, that have never known a world without smartphones, without technology, without this information overload, and it's how do you kind of filter the signal out of all the noise? How do you get, when there's so much possibility, when there's so many things to know, and everything is just the scope, like the perceived scope of reality is just insane now. Even if it's not really, at the end of the day, you got to just, choose a profession, get good at it, do the work. So what I'm trying to do right now, my younger cousin, I'm going to be seeing him in a couple of weeks, and I've, used the rover to basically scan myself, and I'm going to take that point cloud, turn it into a model, and 3D print it, and I'm going to give it to him as a gift. I promised him I would, and that's hopefully, get him excited to get the gears turning, because, even though, a lot of this technology seems insane to understand and it's all complicated, it's completely knowable. You can figure it out. People are writing books on how to solve it, how to create it. It's, nothing, no aspect of reality of humanity is truly static. We're always changing, and every person that's coming into college, that's going to be graduating, will have the ability to affect their will on society in some way.
Oh, exactly.
How do you teach that? That's always the biggest struggle.
Well, that's good, because, and I think that's part of a deeper conversation for another place, another time, and probably adult beverages. The whole mentoring concept, and I think unfortunately there are some older generations among surveyors that think that it is only one way, and it's only old to young, and that's not necessarily the case. And I think obviously the younger generation sees the value in that. You've been the recipient of mentors, and for you to very quickly take what you've learned and help apply that to a younger set of surveyors coming in, I think is very important. So I applaud you for taking what you've learned and turning it around and making it useful much sooner than most. So that's fantastic. I guess so. You taking all of this in this short conversation, where does this lead Michael Bleeker for the future? What's your short-term goals? What do you look to accomplish besides building this super cool autonomous vehicle that's going to be a data collecting machine? But where's this taking Michael to the next? What's that next level? So
the immediate short-term goals is, finish a degree, get licensed, and start a boundary company to start. There's so much work. This is an overwhelming amount, even with the real estate, economy just being as crazy as it is. Like, there's just a need for surveyors. So that's going to be probably the backbone of whatever company I end up creating. And then over time, we'll figure out, how to incorporate this technology into, the business, and eventually, figure out, client discovery and things like that. And we'll figure out what specific angles to take it. But,
very good.
This technology, it's all emerging and it's nice and it's cool, but, how do you take your knowledge and turn it into money? That's, at the end of the day, the big question everyone always needs to worry about.
Exactly. Yeah. At the end of the day, it is a business, and end of the day, you've got to put food on the table. So yeah, you're right that you can have all these grandiose, wonderful plans for things, but if it's not filling the bank account,
you can't eat dreams and visions.
Can't eat dreams of it. I like that. I think I'm gonna. Yeah, I'll credit you that, but I think I'll keep that. So I guess and I'm trying to be considerate of your time as well. So my big final question usually for everybody is, how does the future of surveying look to you? I think we've kind of laid it out here, and based upon your short and longer term goals and what you're trying to tie together with all the things you're learning, I think I've got an answer, but how does the future of surveying look?
It's incredibly exciting. Surveying is quite possibly the oldest profession in the human race. Even when we were cavemen, chasing down antelopes and, gathering berries, the adventurous humans would go out, they would figure out where all the stuff is, come back, do a cave painting on the walls, get excited over the fire and go do the thing. Even now, our modern technology, the Curiosity and Perseverance rovers, the James Webb Telescope, the humanity's magnum opuses, it's all just surveying insurance, and it's a profession that has just constantly been evolving and, always changing, but it's, a core part of, humanity, really measuring, trying to quantify the world that we occupy and how to make the best of it. A lot of guys are, I think, unfairly pessimistic about, the future, but it's brighter than ever. It probably always will be. Yep.
I agree. And I think that's, that is a great not just a viewpoint to take, but a great philosophy to have going forward, because it is everything we're seeing is, like you said, it is about knowing what's around us, knowing what we have, knowing what is out there. And you're right. I've always been told it's the second oldest profession, but we won't go there either. Sure. But yes, you're right. And, that's I think that's the beauty of it. Talking to the NJIT students and the Rowan students and all the other people across the country have been able to talk to, even the high school students we talked to recently. You're writing your own ticket, because there's I don't think at this point there is a ceiling on this. So
I would argue that there isn't.
Yep. Well, kudos to you for putting this all together, for having a vision and having an idea of where you want to take it, because I think those that are a little more organized in their thoughts going forward, and you are, and that's why I was looking forward to this conversation. I really look forward to seeing your further enhancements on Gunther, and and where you're taking the robotics itself, because you're right. It is the technology, and how we harness that is going to help determine how successful we are. And you've done a great job putting stuff together, and give our best to Dr. Potts, and we appreciate you taking some time to come in. And I tell you what, if you don't mind, I think I'm going to keep your card here in the Rolodex. I think we need to check up in a little while and see how the progress of everything's coming. Of
course. I'd love to have you on again.
That sounds great. Well, that'll wrap us up for this week of Surveyor Says. Thank you, Michael, for joining us. Wherever you subscribe, go ahead and hit that like button. We appreciate all of our listeners, and we do have some great conversations coming up. I don't want to tip my hand a little bit, but we do have some really great conversations like Michael here. There's been a bunch of people that have come out of the woodwork that really like these conversations, and we'd look forward to bring them to you. So thanks again. You've been listening to the Surveyor Says podcast, brought to you by the National Society of Professional Surveyors. If you have any questions about today's episode or any other topic, please email us at info@nsps.us.com, and we are here to help. Visit our website, nsps.us.com, to learn more about our association, the programs we administer and support, our sustaining members, and information about future episodes of Surveyor Says. Subscribe to the podcast on iTunes, Apple Podcasts, Google Play, iHeartRadio, Spotify, as well as our podcast host, Podbean. And remember, it's a great day to be a surveyor.